All right, let's just jump right in because we're tackling one of the biggest, most mind-bending questions out there right now. Is AI actually conscious? And we're going to explore this through the eyes of neuroscientist Dr. Jean Aroux, who has some really strong and frankly fascinating ideas about the massive divide between artificial intelligence and the human brain.
Yeah, this is the question, right? The one everyone's talking about. As these AI models get shockingly good, you can't help but wonder, is there anything actually going on inside? Is there a light on in there? A subjective experience?
You know, a lot of experts are kind of playing it safe on this one. They'll say, well, maybe, or it's complicated, or we just don't know yet. But Dr. Aroux, who spends his days studying the actual messy biological details of the brain, he comes to the table with a much, much stronger opinion. And there you have it, straight up. For Dr. Aroux, looking at the scientific evidence, the probability that today's large language models are conscious isn't just small. It's zero, a flat zero. Now, that is a huge claim. So, what in the world is it based on? And look, this isn't just some gut feeling he has. His entire argument is built from the ground up, looking at how brains actually work. And it really all comes down to two huge fundamental differences between biological brains and digital AI. So let's break them down. Okay, first up, complexity. And we're not just talking a little more complex here. We are talking about a difference in scale that is so vast it practically becomes a difference in kind. Just look at this comparison. In an AI, a neuron is, well, it's a simple piece of code, a single point in a massive flowchart. But a real biological neuron? Whoa, that is a living thing. It's an entire universe packed into a single cell, buzzing with literally billions of intricate chemical processes. It's not just an on-off switch, it's a tiny, super complex, living computer all on its own. So you hear people say things like, oh, these AI networks are getting as complex as a rat's brain now. Well, Dr. Aroux has a pretty blunt response to that. He just calls that view naive. Why? Because it completely ignores this astronomical level of complexity that's happening inside every single one of our biological neurons. All right, let's get into the second big difference. And fair warning, this one's going to bend your brain a little. It's this idea that in biology, the hardware on the software, they're not separate things. The very stuff something is made of dictates what it can compute. Think about how we build AI right now. The main game plan is just to scale up. You throw more data at it, you add more parameters, you get more powerful chips, but it's all happening on one single level, the network level. You're just making the same system bigger and bigger and bigger. But the brain? It's a whole different ballgame. It operates in this constant, dynamic loop that crosses all these different scales. You can have a tiny little event happen at the molecular level that cascades all the way up to change the entire network's activity, which then affects how you act in the world. And then that action can actually feed all the way back down and change things at the molecular level again. It's this wild, continuous conversation between the microscopic and the macroscopic. And here's the kicker. This isn't just about being more complex. This back and forth across different scales creates a fundamentally different kind of computation. The brain isn't just running software on its hardware. The hardware is the computation, constantly changing and evolving. Dr. Aroux has this fantastic analogy for why it's so dangerous to only look at one level, like the firing of neurons. He says it's like going into a massive, complex rainforest, hearing a single person clapping, and then deciding, I get it. To understand this whole rainforest, I just need to study the clapping. You see the problem? You're missing pretty much everything else that's going on. Okay, to really hammer this home, let's look at a pretty radical idea from Dr. Aroux's own work. It really shows how much these nitty-gritty biological details matter. It's a theory that basically flips our whole idea of how the brain is organized upside down. First, you gotta know this term he uses, which is just great, cortical chauvinism. It's a funny name for the standard textbook view that the cortex, that wrinkly outer part of the brain, is the king, that it's where all the smart stuff, all the consciousness happens. But the shallow brain idea says, maybe not. It suggests that a much deeper, older structure called the thalamus, which is usually thought of as just a simple relay station for your senses, is actually the real master conductor of the whole orchestra. It might be treating the entire supposedly deep and complex cortex as one big, shallow sheet that it can manage. So how could it possibly do that? Well, the thalamus is in this perfect spot to be a control hub. It gets signals from every part of the cortex, and it can send signals back to control every part. And here's the wild part. It can actually reach into the brain's wiring, right down to the individual branches of a neuron, the dendrites, and just decouple processing loops. It's like it can turn entire brain circuits on and off, which lets it manage the cortex's insane processing power.
So what's the point of all this? The big takeaway is that the brain's real power, its real algorithm, is written in these super specific, messy biological details. It's about where tiny receptors are placed, the exact shape of a dendrite. All this stuff is completely 100% missing from the AI models we're building today.
Okay, so we've got this huge gap, right? A gap in raw complexity and a totally different style of computation. So where does that leave us? Does it mean creating a conscious machine is just impossible? Well, usually this debate gets stuck between two extremes. On one side, you have the naive computationalists. They're like, hey, just build something that acts like a brain and consciousness will just show up. Then on the other side, you have the biological naturalists who say consciousness is some kind of special biological magic that can never, ever be replicated in a machine. But Dr. Arou says, hold on, there's a middle ground here. He stakes out a third position, a path he calls biological computation. And honestly, it feels like a much more sensible way to think about it. So, what is biological computation? Well, to use his exact words, it's a freaking complex computation. And that's the key. He's saying it is a computation. It's not magic. But it's a kind of computation that is so fundamentally tied to its physical biological body that you can't just copy the code and run it on a silicon chip. The medium is a massive part of the message. And this all points to one really clear, really powerful conclusion. If we ever want to build an AI that's truly conscious, just making our current models bigger and bigger, that's not the answer. That's like trying to get to the moon by building a taller ladder. You're not just on the wrong track, you're using a completely different kind of technology. Which leaves us with a much bigger and, frankly, a much cooler question to think about. The question isn't, is my chatbot conscious? The real question is this. If just scaling up digital computers won't work, what kind of weird living machine, one that's actually built on these messy, constrained biological rules, could ever wake up? That's the real puzzle we have to solve.